What's up? What's up? It's your man Jimmy Chan. All right, so let's talk about building linear models from data. So we're talking about scatter plots, right? So in other words, we're given a bunch of points and we gotta figure out a best fit line. So first we need to plot the points, determine if it's linear or nonlinear, draw the best fit line, write the equation for the best fit line by picking 2 points that you can read unless specified. So you might have problems that says, hey, pick these 2 points, find the equation of the line. And then I'm going to also show you how to use Desmos test mode on how to find the equation of the real best fit line. All right. So here I have some data, right, from a bunch of baseball teams, the on base percentages versus the run scored, right? So I have some X, some Y values, right? So obviously it's going to create a bunch of points. So I'm going to type those into Desmos by, first of all, what I need to do is hit this plus sign and select table. And it'll give me a table. And if you notice right here that it gives me X1, Y1. So X1, I type in all the X values, Y1, I type in all the Y values. And notice that this is green, so that means it's going to give me a bunch of green dots. All right. So for me, if I was to write an equation for the best fit line, then when I decide to pick a line and start to look at the data, I want to move it in such a way that where it might connect 2 points, right? I might have to move the top a little bit, I might have to move the bottom a little bit to figure out where the best fit line is. So as I move, I want to check out, the number of points on this side and how far they're away from the line. And if I add all those distance up, is it equal to the distances here, right? So that's what I want to try to figure out. And if these are further away, maybe I want to pick this line and make it maybe closer this direction so that I kind of feel more comfortable with it, right? So maybe I need to, it's hard to move this because it snaps into place. Let me see here. Maybe that would be a pretty good best fit line, right? Because if I look, there's 3 points that are pretty far away, and then there is 3 points that are pretty darn close, where this has 4 points, 5 points, 6 points. Ooh, that's a lot of points, right? Because there's 2, 4, 6 here, so maybe I need to move it a little bit more. But anyways, let's say that this is my best fit line. Then what I'm going to do is I'm going to find 2 points, and I always want to try to connect on 2 points that I can read, right? And from those 2 points, find the slope, right, by using these 2 points, and then get my best fit line, right? Or doing it that way, right? So I can pick those 2 points and go from there. Now, do I know what those points are going to be? I don't recall. Let me see. This is around just under 700. Let me see. And then it probably would have helped if all of these were in order as well, right? So, but this is below 700. Okay. So let me see, 690, looks like 690, right? That's probably about right. That's 650, 60, 70, 80, 90. So that point must be this right here, which is 31.5 comma 690. And this point over here, this is 750, 760, 770, between 770 and 780. So I'm guessing it's this point right here. So actually, let me do it this way. That would work. So the first one, I would pick this point here. Wow, that's really thick. Let me see here. Can I make it smaller? Smaller. Yeah, there we go. That works better. and then duplicate, and then the other one I said is just below 780, so it must be that one right there. So this point here is 33.1 comma 778. Okay, so the slope will equal to 778 minus 690 over 33.1 minus 31.5. Let's see what that equals to. In my hand-to-dandy calculator. Let's see here. 778 minus 690. 330.1 minus 31.5. And that's going to give me 55. Right? Then I can pick one of the points. And let's see here. Let's go ahead and pick. It doesn't really matter. So I'm going to go with the 690 is equal to 55 times 31.5 plus b. So 31.5 times 55. And then I have to subtract it over. So my b is going to equal to negative 1042.5. Okay. So let me see here. So it's going to be y is equal to 55x minus 1042.5. All right. So that is, of course, with human error, right? With human error in terms of getting that equation of the line. All right. So how do I go about doing it to get the real best fit line? Well, that's a great question. So after I put all of these in the table, on the second box, I want to plug this in right here, right? If you want to look at it, here it is. Now, notice what I said, right? Up here, this is x sub 1, y sub 1. So your equation that you put in has to mimic that, right? So if this x sub 1 and y sub 1 was x sub 2, y sub 2, or x sub 3, y sub 3, then you got to put it accordingly. All right? So y1 is approximately mx sub 1 plus b. And then it will plot it, and it will tell you that this is a pretty darn good line, right? Anything close to 1 or negative 1 says it's a pretty darn good line. And here is my actual slope and my actual y-intercept. So this equation here should be, actually, since it's, now this right here says that the line is going to be in black ink. So let me go ahead and write this in black ink. So this will be y is equal to 57.3455x minus 1120.75. So that is my actual equation of the line, which isn't too, I didn't do it too bad of a job, right? I mean, my slope was 55, their slope is 57, so I was a little slightly off, which would throw my y-intercept off as well. But for a blindly done and see what happens type, that's what's going to happen. So when you type this in, what's going to happen is that's going to draw a line for you of the best fit line. And if you notice here, what they drew, that's the actual line, it only met 1 point. Right, which is one of the points we picked, which is a 778, I believe. Okay, because this is 750, 760, 770, 780, so right below 780, so it is that point right there, right? So it wasn't too bad of a best fit line that I drew up here. Again, it is gonna be time consuming to try to figure it out, and of course, in order for us to draw our own conclusion here, we do need to try to figure out spacing from the point to that line that you're drawing. Okay, so make sure that you're careful with that as you're going. All right, well, I hope that answers your questions. If there's any other questions, please let me know. Talk to you later. See ya. Bye.